Hi, I'm Cameron from PI Exchange, and today we'll be going over how you can experiment with machine learning applications using the Playground project in the AI and Analytics engine. Let's explore the engine using the Playground project that is already loaded into your account. A project contains datasets for the machine learning models to train on, data preparation recipes, and machine learning applications. Let's go in here under apps. We can see in the Playground project, there are 8 different applications, all of which are different examples of possible use cases and machine learning problem types. Apps can be built in the engine in 2 different ways. The first is through using the FlexiBuild Studio. This provides flexibility and can be used to make predictions for regression and classification problem types, or grouping similar items with clustering algorithms. The second option is our machine learning solution templates. These are structured approaches that provide guidance in solving specific business problems like customer churn, customer lifetime value, and demand forecasting. The use case that we'll be experimenting with today is predicting whether people survived on the Titanic or not, which is a binary classification problem. So we'll be using the FlexiBuild Studio. The Titanic problem is a classic data science and machine learning exercise where we use the data of passengers to predict whether they survived or not. Let's have a look at our training data that we'll be using to train the machine learning models. So if we go to apps on the left and click on sinking of the Titanic, we can have a look at the app setup, which is already being created for us in the Playground project. Show details, and we have the Titanic dataset here. Let's click on view preview and have a look at it. On the top here, we see a number of columns, which are also known as features, and they will be used to predict this feature here, survived. With any classification problem, we need the training data to be labeled, which simply means our target variable is filled out, which it is. Some of the other features that we've got here is P class, which is the ticket class, as well as their name, sex, age. Other features we've got here is ticket. Interesting thing about here, and which you'll see in other spots, is that they're not always completely filled out. Fare, cabin, and finally embarked, which is the city that they embarked from. Next, let's do some exploratory data analysis by clicking on analysis here. We can see in this single column tab, we can get a general idea of how a particular feature is distributed. So for example, let's click on the survived column, and we see the majority of people have a value of 0 with 549, and 342 people having a value of 1. In our case, that means that 549 people didn't survive and 342 did. Let's also have a look at sex, for example. So we can see majority of people are indeed males and a minority are female. Finally, let's have a look at the age column, which we see is a roughly normal distribution. Let's go over and click pairs. And what this does is give us a visual indicator of the relationship between 2 features. So let's cross out a few of them and let's look at survived and sex. So this is known as exploratory data analysis, where we're just trying to understand the data a little better. So what we can see here is that there is a very high density of males that didn't survive compared to females, and vice versa. There's a bit higher density of females that did survive compared to males. Now, this might be telling us some stuff about the data, and it's good to help us understand what's going on a bit better. So now that we have had a look at the data set, we can X out of this tab and go back to the app setup. The next stage in the process is data wrangling, also known as data preparation or data pre-processing. And this is where we transform the data to get ready for machine learning. In the AI and analytics engine, we have the concept of a recipe, which is a set of data transformation actions that can be reused again to help speed up the machine learning pipeline. Let's have a look at the recipe that's being created for us here. So this has 7 actions that has been done sequentially, and the result of these 7 actions is that we've created a few extra columns or features. The first of which is a feature called has made a name. Now, this is one we've created ourselves to try and help us get a bit of a stronger prediction. We can also see number of cabins has been created here, as well as family size, which has been created using 1 plus the number of siblings, spouses, parents, and children. So let's go back here now. Now that we're back in the app setup, we can see that we originally had the raw data set. We've ran it through a data transformation recipe, and that's left us with a processed data set, which will be used to train the machine learning models. Next in the pipeline is building the models themselves. Now, this has already been done for us, which we can see here, or under model, we've got a list. So we've already trained 4 models, which will be in your playground project as well. But we can very easily create our own models. So let's do that with create another app using this setup. And we can see we have the same app setup here. So let's click here, and it's already been set as our training data set. And this is the processed, or we could use the raw if we wanted to as well. Let's click on save and continue. And here is where we need to define what to predict. So we are predicting the survive feature. Because this is a 0 or 1 or a yes or a no, as we said, this is a binary classification problem, which has already been selected as the most suitable. And we're trying to predict whether the survived column equals 1. Configure the train test split. With our training data, the models need to evaluate it somehow. And the way it does this is a random split where 80% of the training data is used to teach the machine learning models what features correlate to survived. And then 20% of the training data set is kept aside to used as evaluation. Standard practice is to use 80%, so we can leave it there. Let's click save and continue. Okay, this is the feature selection stage. Now, we can pick as many of the features that we want involved. We can manually select it if we want to, or we can just let the engine select the best features for us. So let's do that. And we can click use recommended selection and scroll down. And here is choosing which particular classification model to use. So again, like feature selection, we can manually choose them, or we can just let the engine train the top, let's say 3 algorithms. And if we wanted to, we can add some constraints based on training time and prediction quality. If you did want to create your own app, you can click start building. But for all intents and purposes, we may as well just use the one that's already been built for us. Let's go back into apps and go back into our Titanic one. Now, as I mentioned before, in the playground project, we already have a number of models trained for us. So we can go and have a look at them here under the models tab. And we're brought to the model leaderboard. If we wanted to, we could train some more models, but we don't need to do that. So we'll just click back here and scroll down. But here is a list of the models that have already been trained for us. So a number of different classification algorithms that have been used with a prediction quality ranging from 85 to 88%. Quick note, prediction quality is not accuracy. If you want to understand a little bit more about our prediction quality metric, you can click here. Let's dig a little deeper into our best performing model. Now we can start to evaluate how our model has performed. By going into insights here, we're brought to the performance tab where we're given a number of evaluation metrics such as precision, recall, and F1 score, as well as the confusion matrix, the ROC curve, and the precision recall curve. These are all different ways to evaluate how the model has performed. If we go have a look at feature importance, we can see how strongly of an indicator each particular feature is to predicting survived. So in our exploratory data analysis, we can remember that sex and survived has some striking correlations visually. And that's been backed up by the feature importance here. So we see that sex is actually the strongest predictor if someone survived or not. Going down, we have the title in their name, the class that they were in, their fare, their cabin number. And we can go have a look all the way down. And we actually see some of the features that we created in the data wrangling weren't all that strong at predicting survived. Let's scroll back up and look at prediction explanation. Here is where we can see an actual example that was used and how each of the particular features for that example affected the prediction. For this example here, they had a 93% probability that their survived feature was 1, which is they survived. And here we can see how each of the features boosted that number. So here we can see because they were a female, that increased their probability by 18%. And we can also see this visually in a chart as well. Finally, we can go to the what if tool, which you have to deploy, but we can manually change the feature values to understand a probability of an unknown data point. Now that we've had a look at the model performance, let's go have a look at the predictions that it's made. Going back into our syncing of the Titanic app, we can see that a one-off prediction has already been made. Now, remember, the dataset that we used to train the models was a labeled dataset, so that's where we know if they survived or not. The testing data we do not know, and that's what we're predicting. So we can click on the one-off prediction here, and we see that the test data has been uploaded. The data transformer, which is our recipe that we added to the training data, has also been used on the test data to make sure that it's in the same format. And then the prediction has been run. Now, let's have a quick preview of the prediction data. So for all of these data points here, we've been given if they have survived as a 0 or 1, as a yes or no, as well as a probability score for each. There's a few ways we can use this data. So we can export it within the engine as a new data set where we can go and use the analysis tools there. We can also download it as a file, for example, a CSV if we wanted to put it into Microsoft Excel or Google Sheets, or we can directly send it to a database, which is what we can do now. We are going to directly send it to Google BigQuery so we can create a dashboard and do some analysis of the predictions that our machine learning models have made. Click on BigQuery. You'll need to upload your credential key here, as well as specify the dataset and create a new table in the database. I'll go ahead and do that now and come back in a moment. Okay, I have sent prediction results from the ML models to a table in Google BigQuery and have imported that data from BigQuery into Looker Studio and created this dashboard. It's not particularly impressive, but it does illustrate how easy it is to send results and make dashboards out of it. And that's the end. I hope you've enjoyed experimenting using the Engine's Playground project. Feel free to create your own apps, your own data wrangling recipes, try and get some better results than what we were able to, and let me know how you did. Thanks.